The RF wireless communication between the pill dispenser and the user. Just quick to tell you about the system properties. We needed a one-way communication system, like I said. We just need to inform the user when the pills are ready and just transmit a signal to the receiver that they can carry around to tell them that the pills are ready. They can just walk over to their station and get their pills. The other thing is also it's supposed to warn the user when the pills are at a low, for example. It would send the signal, and then on the LCD they can come and say, pill 1 running low, restock your pills, which they can do. And we needed a system that would work for a considerable amount of range. It's rated at 3,000 feet, but that's line of sight, which obviously you can't really attain within a house. But I tested it walking around from our senior design lab all the way outside to the quad and going around the building, and you can clearly hear and receive the signal. I was aiming to try and make it as small and wearable as possible so that the user can carry it around without it being a burden on them. This is our RF transmitter. This is what's inside that box. It basically runs at 420 megahertz, requires a voltage between 2.1 to 3.6, optimally 3 volts, and operating temperature is on there. This is the receiver encased in the plastic box that I purchased, and it also operates obviously on the same frequency. Requires somewhere between 2.7 and 3.6 volts, optimally also at 3 volts DC. I was trying to get it as small as possible. The transmitter is like 2 inches by 4.5 inches, and it doesn't really have much depth because it's a thin board. The receiver inside its plastic casing is about 2.5 inches by 5.5 by 2, which is a little bigger than I hoped, but I couldn't find an enclosure small enough for it. The range, as I said, is up to 3,000 feet. However, this is line of sight. I didn't measure exactly how far it was, but it worked, like I said, pretty far enough. From downstairs all the way outside to like Royal Hall, out here on the quad, and then around Florsheim Hall, the building, and then back in, and I walked, and the signal was clear, the buzzer sounded, and the light lit up as well all the time. So how does this work? The RF, the only time that it's going to be employed is when a pill is dispensed, or if we want to warn the user of anything within the system. So basically, like my team members said, the motor rotates and you get a pill that goes down into the cup and it covers that sensor, which alarms the user that the pills are ready. As soon as that happens, the microcontroller sends me an output of 5 volts. That's what it's rated at, and I have like a voltage regulator soldered in here on the microcontroller output to reduce it to 3 volts for the transmitter. And then once I get that signal, it goes through my transmitter, sends the signal, and the signal is kept on until the cup is removed, because there's that switch behind the cup. As soon as the cup is removed, that signal from the microcontroller gets cut, to stop annoying the user to take their pills. And then if the user returns the cup with the pills in, it still blocks that emitter collector, so it would still send the signal. However, if the line of sight is clear, then the signal is stopped, and then then the machine works, keeps on going. The system keeps on going for the next dispensing times. So it checks for pills if they're returned in the cup to make sure that the user takes them, and it also warns them if their pills are running low, which are 2 important aspects of that. As for my cost list, it costs $60 each for the transmitter and receiver, about $5 for the plastic enclosure, and a total of about $125. And we're going to run through a short demonstration, but we want to thank you for your time, and we will be taking any questions that you have. Thanks.